let's explore the different splitting and orbital diagrams in the crystal field theory for complex ions. So the first example here, these two are both 4 octahedral complexes with a coordination number of 6. Now there can be 2 situations of drawing these things, but familiarize yourself with the fact that the higher level has 2 orbitals and the lower level has 3 orbitals. The top one is called EG, the bottom is called T2G. Now there are 2 ways of drawing it. If they are a diamagnetic metal ion, then you could have a situation where it's weak field and another where it's strong field. So that will depend. If you have a strong field ligand, that means you would make sure that your difference in splitting energy has a longer arrow than the weak field ligand, and this is arbitrary based on what you're comparing. So they can also say high spin or low spin, and that is the case when after you fill in all the electrons for the metal electron configuration, you notice that one of these arrangements have more unpaired orbitals, unpaired electrons, for example, because number 1 here is weak field, that means it can fill up the top before even finishing the bottom, whereas for strong field, it must finish the bottom before filling the top. That means typically a weak field ligand is also high spin, because their electrons can spin at a higher orbital. That's why they're high spin, because they are weak field, weak energy splitting between them, so they can have the energy to go up a level. So typically then the weak field ligands have more unpaired electrons, so that will be the trend you see, whereas strong field ligands will have low spin. If they are paramagnetic, that means some electrons are unpaired. Think of it like this. Strong field means there is a high splitting energy, so electrons will not have enough energy to fill the top without filling the bottom first. So that means they can only spin at a lower level. So low spin is a strong field and weak field is a high spin. That's for tetrahedral. Now we can also have, that was octahedral. Now we'll talk about the tetrahedral arrangement. So tetrahedral arrangement is just basically the flipped version of the octahedral, given that your orbitals at the bottom is going to be, it's just like your E is put at the bottom and your T is put at the top, except first there is no more G, no more G, so you just say E and T2. And of course then E has 2 orbitals and T has 3 orbitals. And the splitting energy is also called delta T, and that splitting energy is smaller than the octahedral splitting energy. So that's why it's called a weak field ligand, because the splitting energy is so small. That means they can fill up the top electrons, the top orbitals first, without even filling all of their bottom first. So that's your weak field ligand, which is then typically high spin because they can spin at a higher level without filling their bottom first. High spin. So that's tetrahedral. And this is usually true for D5 and D10 metals and also larger ligands. So for example, copper plus, zinc 2 plus, manganese 2 plus. And also their orbitals is also just like the reverse dz squared and then that. Okay. So the last one here is square planar. So square planar is usually D8. And square planar will be like this. So their orbital splitting is quite unique. Their splitting energy between these 2 top orbitals is the same as the splitting energy for the octahedral. So these guys, the square planar guys, have the strongest splitting energy, which means they are low spin. Because if you're filling in their electrons, you have to fill in the bottom first, and their bottom is a little unique as well. You fill it in this order: 1, 2, 3, 4. Okay, it is still low spin because then you start filling 5, 6, 7, 8. So you're filling in the bottom in a sense. You're filling in the bottom before filling the top, so the electrons are spinning at the lower levels. So that's why it's strong field and it's low spin.